Staph epidermidis is an organism that lives on everybody's skin and has been evolving to be optimally suited to live on human skin. Staph epidermidis is certainly there when MRSA comes in. So we think that the Staph epidermidis, some of them died and their DNA was floating around in the medium. And MRSA actively brings that DNA through its membranes to incorporate that DNA then into its genome. So the acquisition of the SPG gene gave, in an instant, gave MRSA the ability to survive on the skin better. So these events where some genes get transferred from one organism to another can have profound effects on the epidemiology and on human health. But we really wanted to know when. We wanted to try to date the occurrence of that particular event, the transfer from Staph epidermidis into the ancestor of USA 300 strains. For that, we used phylogenetic techniques. This is the important acquisition event. This is the donor. This is the recipient. We can see when did that acquisition happen. And what was really interesting here, the highest probability is that this acquisition event happened very, very recently in 1997, immediately prior to the spread of USA 300. So what that said to us was that there's something really important about this event for the biology of USA 300. It's entirely plausible that event actually happened on a human, on their skin. Nobody has a good idea of how long Staph aureus has been living with us, nor for any of the other staphylococci that live on us. But it seems as though they've been with us for a very, very long time. The takeaway message is that we are constantly evolving along with the bacteria that populate our bodies.
There are trillions of bacteria on and in our bodies. And if we want to know exactly what is coming off of a human, we really need to create a tightly controlled experimental context. This project is all about trying to find out just what a human is giving off, because no one's ever been able to study just the bacteria coming off of a person. Okay, so we're going to let the room settle down for 10 minutes and then turn the filters on. Good? Okay. When a human is in a room, we're constantly giving off a lot of bacteria. Every time I breathe, when I'm wiping my hands, I'm giving off some bacteria. And these cups have a sterile, clean filter right at the base of them. So bacteria that are being sucked in that air are going to stop at that filter as air moves through. One thing that we know already, just by seeing the first bit of data that we've had back, is that we see certain bacteria that are always showing up in different amounts. But then one person might have a set of bacteria that don't show up in the other people's samples. I have a dog, and so we might be able to see dog-associated bacteria. Or we might be able to see that I went for a hike a few days ago and maybe it's still on my clothes. We know that there's a lot of variability between people, but we really don't understand much about how that might or might not actually affect our health. This is one of those fields where we don't know much at all. We're learning new things every single day about the interactions between bacteria and our bodies that we never understood before.
We will always have bacteria on us. We will always live with bacteria. We can't, in some ways, live without them. So understanding what makes a bacterium good and what makes a bacterium bad and what makes a bacterium benign and what makes it cause disease, those are the crucial questions.